Okay, we'll continue on the maintenance of steam generator. Usually for the operation of boiler or steam generator, there are typical problem which were encountered by the operators, namely the tube scaling, tube fouling, slagging, foaming, tube corrosion, and also acoustic embrittlement. We will look at each of the issue or problem one by one. Okay, on the corrosion side, I think this is fairly straightforward. Okay, the definition of corrosion itself, metal oxidation, which form rust that goes into solution in the boiler water. Usually it happens in the boiler tube, okay, either on the furnace wall, superheater tube, reheater tube, and all other tubes that we have in the boiler. Okay, when you have oxygen and water, okay, together, it will create some kind of rust or metal oxidation. So this one is a common problem associated with the boiler, because it's kind of difficult to prevent water to form, especially when you have combustion inside the furnace. Okay, and then this is also, I mean, the corrosion is also caused due to the electrolytic action between two metals. When you have two metals, there are also potential of giving corrosion problem. So as part of the prevention method, okay, what we can do is that we try to segregate or separate the oxygen. So in other words, we try to remove oxygen from the system. Let's say, for example, inside the water or steam that's flowing, we try to remove oxygen inside the water. So this one is common. We can do that via a process called deaeration. Okay, deaeration, where we remove the oxygen inside a deaerator. Or we can also use another method, which is called the sacrificial anode. Means that we introduce a metal that become, I mean, sacrifice instead of rusting on the tube. So in other words, the action or the process will involve another material that we introduce to become the sacrificial anode. This is a typical pictures taken to illustrate the corrosion and also tube scaling. So we can see here for the tube corrosion here, it is you can see the rust, okay, happening inside the tube. Okay, we don't want any corrosion inside, because sooner or later it will create a wear, which eventually cause the tube to leak, or maybe tube splitting due to the corrosion. Okay, another issue with the boiler, with the operation of the boiler, is when we have a scale formation. Scaling is also an important parameter that we need to look into for proper maintenance here. Okay, the definition of scaling itself is that when there is a hard substance created when mineral salt, okay, come out of solution as their solubility drops. This is the illustration of scaling. We have steam flowing or water flowing inside the tube. The outside here is the heat or the combustion. Okay, when you have water circulating throughout the boiler, okay, even though the water has been treated, we treat the water to remove any mineral or any impurities from the water, but somehow there are maybe a very minor presence of mineral salts inside there. So when you have water keep on circulating, you know that we have the system to happen inside in a cycle. So maybe there are some kind of evaporation of water or leaking of water. Sooner or later, the mineral that there is, I mean the solubility of this system drops. It will create the mineral. I mean the mineral will be obvious. So the mineral, in other words, it come out from the solution, and then it sticks to the inner tube, okay, to the inside of the tube, and because of that, it will disrupt the heat transfer from the combustion, the heat here, into the water. And then the efficiency of the heat transfer becomes lower, or the efficiency is dropping. Typical components or typical material that we have for the scaling is calcium sulfate, calcium and magnesium carbonate, as well as silicate. This is quite a hard substance that stick to the inside tube. Okay, it adhere or sticking directly to the heating surfaces, substantially decreasing the heat transfer efficiency. So what happened when this when this happen? Okay, it will create metal fatigue or failure. It will cause overheating, okay, of the tube. It can also cause energy waste, and therefore somehow we have to do maintenance, high maintenance cost, and also safety risk. The cost of the tube is quite expensive, because the tube needs to be of a high quality, because it will be used to withstand such a high temperature. So how do we prevent it? Okay, we can do the prevention by having a settling tank. Okay, we try to make sure that the water is free from the mineral salt. So this is where we have a distillation of water. We can do chemical treatment, okay, by injecting or by putting in some kind of slake lime, soda, as well as phosphate. This picture illustrates an example of the tube scaling and corrosion. So you can have scaling inside the tube, right? This is an example where the tube fail, okay, because of the scaling as well as because of the corrosion. Okay, clip failure also happen. This is an example of the reheater tube, okay, due to the thick oxide scaling that happen on the tube. Okay, the next one is on the fouling. Okay, fouling is actually the accumulation of ash on the heating surfaces. So similar example, this is the tube, and then inside here we have water. Now instead of metal forming inside, okay, we have accumulation of ash, okay, forming outside the tube on the surface of the heating at the outside here. So if, for example, if we are burning coal, okay, coal produces ash. The ash will stick to the outside layer of the tube. So this also create lesser efficiency of the heat transfer. So the heat transfer become less. So in other words, you are wasting the fuel, and then if the accumulation of ash becomes higher and higher, then the heat transfer will be very, very low. So it occurs when the volatile matter, so we are talking about the coal combustion, we have aluminum oxide, silicon oxide, and etc. They coexist together and then they stick at the outside. So this is fouling. So how do we prevent it? So one way of preventing the fouling is to approach temperature of convection heating surface to be limited, okay, such that it is under the vapor point of the volatile constituents. So we have to control the temperature, which is kind of very difficult to control, yeah. Approximately 800 degrees Celsius. Okay, usually we have to live with it lah. I mean, the ash will keep on accumulating on the outside surface. So the second prevention method is that we can use soot blowing method. Okay, soot blowing is that you blow some kind of steam at the outside of the tube here, just to remove the ash that accumulates on the surface. Okay, and then we have slagging problem. Okay, slagging. What does it mean by slagging here? It is a melting ash that adhere to the furnace wall and also heating surfaces. So there are distinct features between the fouling and also the slagging. So fouling is when you have accumulation of ash on the surface. Now when the ash, let's say ash undergoes combustion here, and then the temperature of combustion becomes very high, such that it is exceeding the melting temperature of the ash, then the ash becomes melt. Okay, it adheres to the furnace wall and also heating surfaces. When that happens, usually the melting ash is very difficult to remove, so you have to keep on doing the soot blowing method. Sometimes even when you do the soot blowing, it is kind of difficult to remove the melted ash on the surface, on the heating surfaces. So in terms of the composition of the slagging, we have more or less similar elements, okay, just like the fouling: aluminum oxide, silicon oxide, or ferrum oxide, magnesium oxide, and calcium oxide, and etc. So this is for the slagging. And one of the methods to prevent, in addition to the soot blowing, we can design the burner zone heat rate to be within the adequately suitable range. In other words, you have to make sure that the temperature of combustion within that area is below the temperature, or below the melting temperature of the ash. Okay, this is a picture showing an example of the tube fouling. You cannot see it. This is the tube. So actually on the tube here we have some kind of metal being formed, okay, when ash melts. So again, the main concern is that it will hamper the heat transfer. The heat transfer becomes less to the water. So the overall efficiency of the boiler will drop as well. Okay, another picture that we take in one of the power station. This is another issue caused by ash accumulation, hardened ash. So you can see how severe is the problem. So let's say we are having rows of tube here, and these are the actual picture inside the boiler during the shutdown. So we go into the furnace, the boiler, and this is how it looks like. You can see there is a water wall here, okay, a rows of tubing system where we have water inside there. Okay, when you fire coal, sometimes the quality of coal is kind of difficult to control. It contains maybe sand and whatnot, and this sand will be burned inside the combustion chamber, right? And then this is the outcome when the coal quality is not controlled. You are having hardened ash being accumulated on this area. So again, the problem is that the heat transfer, of course, it will become less. And then it is kind of difficult to remove this hardened ash, even though we use the soot blowing method. Somehow the hardened ash stays there. It is, I mean, the behavior of this hardened ash is just like a rock. So you have to manually remove the hardened ash, okay, during the shutdown. Okay, the soot blowing process, okay, they are actually using a soot blowing gun inside the furnace. So let's say this is the illustration of the boiler or steam generator from the side view. So you are having burner area or combustion area. This is where combustion happen, coal injected, air is injected, combustion happen here, right? On at the top here you have a superheater platen, a reheater platen, and whatnot. The soot blower, it is located in certain areas within the furnace. For example, you can see these are the injection port for the soot blower. Okay, usually it is very close to the superheater tubes and also reheater tube. This is an illustration on how the soot blower works. Okay, this gun will be inserted on that surface. Then they use they are tapping the steam somewhere and spray it on the tube. By doing that, it will remove all the accumulated ash on the surface of the superheater tube, reheater tube, and whatnot. Next, we have a foaming problem. Okay, foaming is actually the concentration. It happens when concentration of soluble salt increases inside the steam. Okay, when you have soluble salt present inside the steam, it will create, or it become the center of formation of a bubble. Okay, it create a bubble in the steam. So we don't want this in the our operation of the boiler. Why? Because it can cause priming. Okay, the bubble will break, and then it will combine with another bubble, and then it create a large chunk of liquid that later it will form a slugs of water. Okay, and when water present in the superheated steam, it will kind of destructive to the steam blade. Water that exists in the superheated steam, it will hit the steam blade, and then it will cause the steam blade to maybe pitting, or at the end of the day the steam turbine blade will damage, not only on the blade, but it also affect any valve that we have, and also the surface of the piping system. So to prevent the foaming, usually in certain location of the system there are steam trap. Okay, steam trap is actually function to allow water to be removed, but it will trap the steam. They don't allow the superheated steam, they don't allow steam to go out of the system. They just allow the liquid water. So this is the function of a steam trap. So usually we have steam trap being located in certain location in the boiler furnace. Okay, and then the last one is the acoustic embrittlement, right? This is another problem usually encountered in the boiler operation. It is actually hairline cracks in highly stressed area, okay, in the piping, due to the high concentration of the alkaline salt. So again, everything here, it is due to the mineral salt that exists inside our water system, inside our water system. Okay, the alkaline salt here, it will liberate hydrogen, it is then absorbed by iron in the steel. It will change the physical properties of the material. Sooner or later, it will damage, or it will create the crack, okay, in our tube. And then at the end of the day, our tube will fail. Okay, either through leaking or rupture. Okay, some picture or example of the steam trap here. Okay, this is a good animation of a steam trap, right? This is the steam trap. It allow water to go out, but it will trap the steam, or it will trap the vapor. And you can have a different configuration of the steam trap. Okay, then we have water treatment. Okay, the water treatment that we have inside our power station, the purpose is to provide the plant with properly treated water, okay, in sufficient quantities to meet the plant need. So this is common. All power plant that that utilize a boiler system, they must treat their water, okay, to be free from impurities, to be free from any minerals and so on. So the water that we want inside our boiler is actually pure water, just like clean. Okay, they don't want any impurities in there. So how do we treat the water? We can use the three method here. Either we can use the chemical treatment, demineralization, or de-aeration. So what does it mean by all these terms? Chemical treatment is very straightforward. You inject chemical inside our water, okay, condition the water to predetermined level by using a variety of chemical, okay, just to make sure that the water is neutral. Okay, we don't want water to be acidic or to be too alkaline, okay, because it will sooner or later it will create a problem to the metal, okay, to the metal tube. Then we have demineralization process, okay, to replacement of specific inorganic salt by ion exchange. We try to remove all the mineral, demineralization. Then we also have de-aeration. De-aeration, as I mentioned just now, in the previous slide, is the removal of oxygen, the removal of dissolved oxygen inside the water. It also remove carbon dioxide as well, okay, by heating and bombarding the water with steam. So to do that, you have to have a special tank, okay, whereby we call the tank as a de-aerator. This is the illustration of the de-aerator. Okay, remember the function of the de-aerator to remove the oxygen and also the carbon dioxide. So that's practically the end of the topic on boiler. So in summary, let's have a look here. The steam generators are used or applied in either utility boiler or industrial use. Utility boiler means that the boiler that is applied to a power station, to any station that produces the electricity. Okay, then for the steam generators, we have two types of steam generators. Either it is a fire tube or a boiler, water tube. And for power plant steam generator, nowadays all power plant steam generator, they are based on the water tube. Okay, you have water inside the tube instead of fire inside the tube. Maybe for the small scale boiler, then we have fire tube. We can adopt the fire tube system. Okay, the type of water tube steam generator. For water tube steam generator, it can be divided into natural circulation, controlled circulation, and so on through boiler. Then the main component, remember the main component of the steam generator, we have boiler or furnace, we have drum, economizer, superheater, reheater, and air heater. So usually if you are looking from the water circulation system, it will first encounter the economizer, and then followed by the drum, and then it go to the downcomer in the boiler, in the furnace, and then go to the riser in the boiler and the furnace as well, go back to the drum, and then it will go to superheater, to the turbine, back to the reheater, okay, and then at the end, at the back of the boiler, we have an air heater. So the performance is actually represented by efficiency. Remember, the efficiency can be calculated either using the input-output method or boiler loss method. Then boiler startup operation, okay, cold startup, warm startup, and also the hot startup. And remember all the conditions for cold, warm, and also hot startup. And lastly is on the maintenance, right? Remember a typical issue problem associated with the boiler. We have scaling, fouling, corrosion, foaming, and acoustic embrittlement. Okay, so you have to understand what does it mean by the scaling, the fouling, corrosion, foaming, and acoustic embrittlement, and also what are the usual method that power plant operators do in order to prevent or at least to minimize this problem. So that is all on the topic number 5 on the boiler. Thank you.